Okay, this problem says a bullet is shot horizontally from shoulder height, 1.5 meters, with an initial speed of 200 meters per second. How much time elapses before the bullet hits the ground? How far does the bullet travel horizontally? Okay, so in this problem, so you're shooting the bullet with a horizontal velocity of 200 meters per second, and you're shooting it from a height of 1.5 meters. Okay. So the bullet goes on a parabolic trajectory and hits the ground there. Okay. So in such problems here, you want to draw your axes. Here's the x-axis, here's the y-axis, and you want to write your acceleration vector and then your initial velocity vector. So here's the initial velocity vector, and here's the acceleration vector. The initial velocity vector in components is 200 I plus 0j meters per second. There's no y component to the velocity. And the acceleration vector is this vector doesn't have any x component, it's all y, and that the magnitude of that vector is minus 9.8 meters per second squared. Or it's so it's not, the magnitude is 9.8 meters per second squared. But anyway, here it is in vector form, gj, where g is 9.8 meters per second squared. Alright, so we have written our initial velocity and acceleration in vector form. Alright, so in this problem, the time of flight, how long it's in air, is gotten by looking at the y direction of the motion. Okay, so let's look at the y component of the motion. And here's one of the equations you've seen in the lectures. Y minus y naught is v naught yt plus 1/2 ayt squared. Okay. Here's the final y coordinate of the bullet. Here's the initial y coordinate of the bullet. Here, that's the initial y coordinate. There's the final y coordinate. And this is 0 minus 1.5 meters. 1.5 meters is the initial y coordinate. V naught y is the y component of the velocity, which is 0. So this term is 0 plus, and ay is negative 9.8 meters per second. So it's 1/2 minus 9.8 meters per second squared times t squared. So what does this equation tell us? Minus 1.5 is equal to minus 4.9 t squared. And so we can calculate t from here. And so t squared is 1.5 divided by 4.9, and that gives us t is plus or minus square root of that, and square root of that is 0.55 seconds. And what we want is the positive root, so the bullet hits the ground 0.55 seconds later. Okay. So now how far does the bullet travel horizontally? Well, we'll have to look at the x motion, x component of the motion. So part B, we're looking at the horizontal distance that the bullet travels. And the x component of the motion is given by v naught xt plus 1/2 ax t squared. Now you can see that the x component of the acceleration is 0. Here the x component of the velocity. The initial x coordinate of the bullet is 0, and there's the final x. Okay, so x minus 0 is 200 times t, and plus 0, ax is 0. And so x is 200 times 200 meters per second times 0.55 seconds. That's how long the bullet was in air. Okay. So the bullet travels 110 meters. Okay. All right. So again, in all these problems, what you want to do is you want to write your initial velocity in vector form, your acceleration in vector form, and then use the kinematic equations to solve these problems. Okay.